Stats 103 and 280. All right. So this is going to go back to, I'm not going to have a lot of definition questions. In fact, mostly I would refer to stuff like population versus sample, being able to identify what's what. Chapter 2, I'm not going to make you create a histogram. There just won't be time with everything else we have to do. At the most, I would give you a histogram, sort of like that shampoo problem. You guys remember that? Had a histogram that was all about how long shampoo lasts people. Yeah, I'm pretty sure I did. I gave you a histogram on a test. It was already created, and you had to identify. Maybe not. Sure. Okay. But that kind of problem could be on there. So really, chapter 3, I'm not going to make you redo standard deviation. I already told you that. There's just mean, median, mode, mid-range, that kind of stuff in chapter 3. There's also percentiles. Remember these? There's no formulas for that, really. Just ideas that you have to know. And it's also where we first get the z-score, of course. You can write that down. You can write its alternative. Yeah, this first was introduced in chapter 3. You got this stuff from chapter 4, the probability stuff, right? You've got probably A or B. Anybody remember that was? What's the basic idea of or versus and? Or is plus. So it'll be probability of A plus probability of B minus. Good. If they happen at the same time, you don't want to count them twice, so you subtract one of them off. And probably A and B. All right, reading them off really well. And then, of course, probability of A given B kind of comes from that earlier one. It's A and B divided by the given. So remember the main idea there was the given is on the bottom. I don't know if you guys remember that. Because when I give you information, then the number of things it could be reduces, so that the bottom, the denominator number reduces. Because that bottom would always be the number of total things it could be. So if I had men and women, and there were like 80 people, but there were 30 women, and so it's probably that it's this given it's a woman. Well, it's going to be out of 30 now. It's only going to be 30 people that match that. So if I give you more information, the bottom becomes how many things are in that new thing. Okay, so hopefully that sounds vaguely familiar. This is chapter 4, that double quiz we did, which seems roughly about 18 million years ago. Let's see, that's chapter 4. Then we get to chapter 5. And the first big thing in chapter 5 is this stuff here, remember? Of course you go, well, when do I use that? Probably when I give you x and p of x in that table form. It's kind of a giveaway. And this chapter 5 is also where we talked about binomial stuff. So you have like the binomial probability. All right. So that's chapter 5. And then, of course, if I give you x, p of x, you have a way to find the mean and the standard deviation. Of course, this is the variance here, right? So you'd have to square root it to get there. I just didn't feel like writing a big-ass square root. If I'm given a binomial, here's how to find the probabilities. But now I have to find the way to find its mean and its standard deviation, right? So those are the best formulas ever. What's the mean of a binomial? NP. Stop. So mu is NP. What was sigma? Square root of NPQ. Kick ass. Okay. So that takes us through chapter 5. And again, if I'm you, I would double check all of these formulas in the book just to make sure that you're reading what I'm writing correctly. Then we get to chapter 6, and this is where we got the good old z-scores. We got this is the first real new thing here. This guy here, right? Let's see, what else in there? Chapter 6. Chapter 6 was where you had the idea of the NAB. There's no formulas you can write down for that. Just the idea. So if I ask you to use the NAB, what's the most important piece of that you're going to have to do? If I say use the NAB to find the probability of that, blah.
What is go up?
The NAB.
Okay. Go up 0.5?
Yeah, up or down 0.5, right? That continuity correction. That's what that clue is trying to remind you to do. Oh yeah, it feels like it was last semester or something. Maybe a different life. So maybe you should be keeping track of, like, I got to ask him about this shit. Let's do an example of this shit. That's maybe what you should be doing right now. Maybe not saying shit so much. don't do what I do. Let's see. So chapter 6. All right, I think that's everything for chapter 6. Chapter 7, we had a ton of these. Remember all these? This is if I ask you, of course, to create I have to ask you to create what would these be for? Making a confidence interval. So you would not use any of these formulas if I'm not asking you to create a confidence interval. For some reason, I have somebody always doing one of these formulas in the middle of a hypothesis test. Makes no sense. I'm not going to ask you, I know we're doing a hypothesis, but let me just ask you to make a no, I'm not going to do that to you. Please don't do that to yourself. And then you have these little things on the side of these little n. Find the sample size required to be within so much. That kind of question.
N equals z times standard deviation. Why? Okay, I have a question about that.
Huh? Yeah.
Never mind. It's just weird. It's weird because of never mind.
No problem.
I wrote the same. That's the same thing, right?
Yeah.
I confuse myself.
Just don't the X symbol maybe confuse. I don't know.
No, it's just the error that I think I try to
Okay.
And
do it
for
twice.
T4s, you just substituted T and S.
Yeah, exactly. So if you wanted to, you can write. It would never happen here, right?
Nope.
With NPQ problems, it's Z or nothing. But for this guy, you could have an alternate version. And we used that once. I don't know why I just put a C on there. Oh, it'll be all right. What does this mean? I really desperately want you to understand. Remember, there's a point where I put Z star and I was supposed to put T star. And my point there is, who cares what you call it? It's the score you get from your sample, right? So Z and T are effectively the same thing. It's just you use whichever one you need for that current situation. And S and sigma are basically the same thing. It's just that if I have to use S, I have to then use T, right? So those kind of go together, and sigma and Z kind of go together, but they all represent the same thing. So there's not really two different formulas up there. It's just one. So that's chapter 7. And then we got into hypothesis test. And the only real new formula from chapter 8 was this guy where we stole this. Right? I don't think I have a lot of people doing that. Notice how these are not hats. These are the P and Q you would get from the hypothesis statements, right?
You have to use Z star.
Yeah, you can put a little star, cool. Now, I mean, if you want to put a formula like this up here, if you want to, but I mean, it's why? It's not different from that one, really. It's mine minus the middle divided by the standard deviation I'm using right then. Mine minus the middle divided by the standard deviation I'm using right then. I mean, so that formula is always the same. Even if you did chapter 9, I'm not going to put that formula up on the board, but you can put the formulas from chapter 9 down if you did that homework, the bonus. There might be a bonus question on the final. And then chapter 10 is all in the calculator. No formulas to write down. Cool. Okay, so if you want something more than what we have up in the board, you better bring it up right now. Yes?
What about 7.4, the new stuff? What do you call
Oh,
it?
yeah.
The chi-square?
Chi-square thing.
Yeah.
You stupid stuff. Yeah. We were kind of busy this semester. So for this, it's going to be n minus 1 s squared over chi squared, whatever you want to call it. So I call it big.
We write
We
big?
can't have words on the...
You
We
can
can
have
write
words
big.
like that.
Okay.
Remember I let you use the word mid-range way back when? Yeah. Certain things you just have to have a word. So that's from section 7, well, depending on which book you got. 7.4 in the new book, 7.5 in the old book. Confidence intervals for the standard deviation. Okay, cool. Yes?
If there was a formula on previous formula sheets that you didn't put up there, can you put it on here?
Bring it up now. It's like I just said. If you want more up here on your formula sheet than I've got up here currently, let me know now.
Can you put mid-range and range? I get confused.
It was on the first formula sheet.
This is true. Sure.
You're making me feel stupid.
Why? What do you mean?
Give me a lot of look. Can you put it or not?
No, I can, but what do you think it means that I don't want to put it up here? I'm probably not going to ask you those kind of questions. Thank you very much.
I'm saying nothing. You're like mode, medium,
So like the standard deviation, we had to do this table before, but now how do I find it? Yeah, so how do you find the median now? Calculator. Yeah, right. That's back when we were just getting into it, and that's easy computational stuff, just to feel like you're getting into the stats mode, right?
Yeah, I can just use the calculator.
Totally.
Can we ask questions now?
Yeah, sure.
Oh, sweet. Can you do number 5? Just 5.
Okay, sure. Alright, so this is a question about the problem number 5 about the Bronx pizza. Bronx pizza. And the correlation problem, right? So we'll do that real quick in the calculator, make sure everybody remembers. On the actual final, since I'm going to actually be here, I want you to bring your calculator up like I had planned before. And you'll have to show me scatter plot with the line of best fit on it. Right? I used to be one of these data points, and now I'm thankful that I've stopped eating so much Bronx pizza. And I'm a little bit lower in the weight department. But now I feel like I'm going to have it tonight. All right. So very quickly here. Thankfully, it's not a very long list of data, so you put the data in.
Wait, what happened? Where did you get all these numbers?
And I'm good to go whenever.
What's happening?
Okay,
I don't have any questions.
where did you get the 22? How did you get
No,
L3
no, no, no,
before
I'm
you
not
got?
even, that's old, that's just
Oh,
here.
okay.
Yeah.
Alrighty, never mind.
Stay with me now, we're just looking at the first two lists. Okay. So anybody playing along, you guys with me? Get your data in there. People leaving, I got some more room here, let's see. Yeah, what the hell? It's all good. So once you have the data in, where do I go next to start doing this problem?
Stats.
All right, stat. Count. No?
Well, for A,
Yeah, for part A. Is part A cool?
I was making copies.
Okay, so you sum up, no, you multiply L1 times L2, right? For L3? You don't do any of it then? Okay then.
So this is not XP of X.
Okay then.
This is all about eventually line of best fit, correlation, coefficient, right? Getting R, that kind of stuff. Here's your XP of X1, right? And that's where you have to multiply them and then, yeah.
Okay.
Yeah. Sure. So real quick, Antonio's got a good point. The very first part of number 5 asks you to make a 99% confidence interval for the true mean weight. The big mistake people make here, and I'm not doing this necessarily to be evil, but you just got to pay attention. Where are the weights? Where are the sample weights? In list 2. So if I do 1 bar stats, I've got to do it on list 2. Cool. Then you get your X bar. Now, in order to construct a confidence interval, what do I need? I need X bar. I need what else? So which one am I going to use for this problem? Which standard deviation am I going to use?
S.
Yeah, good. S, because this is a sample we put in there, right? Which implies, what are you going to have to use? So we're using this guy here. I know I'm using an S score, which means I'm going to have to use a T-score. And do I tell you what you need to know? I know I have to use a T because it's S, but what else has to be true?
Has to be normal.
And I tell you here that assume it's normal. Is that cool? So be real careful. And a constants test or something else. If I tell you it's normal, you still have to write it in that step. You still have to say, we're told it's normal. Don't just think, oh yeah, you said it's normal. You got to show me so I know that you're looking for it, right? All right. And then what would my degrees of freedom be here?
8.
Yeah, because n is 9, so degrees of freedom is 8. Cool. I want a 99% confidence interval. You guys is that part A okay?
Yes.
All right, everybody. Okay. And it's on the answer key anyway, so. And then the rest of it, anybody need to see it worked out as far as getting the line of best fit and all that kind of stuff up there?
Yes.
Yes? So if I go, where do I go for the line of best fit? Good. Well, once I have the line of best fit, I'll go there. How do I get the line of best fit? Good. The one that's got a line in it. It's kind of a giveaway. Right? And it defaults to list 1 and list 2. That's exactly where I put my data. So what's my line of best fit? Put it here for myself. So I get negative 2.87x plus 218.6 about. Is that cool? And then now you put that in like, let's just say you put it into y equals negative 2.87 x plus 218.6. Now, of course, if I just hit graph right now, I'm probably going to get something very strange. I think I've done this enough. What do I have to hit? Zoom 9. Yes. Anytime I put new data in, Zoom 9.
And so that's what we're gonna have to show you?
That's what you got to come up and show me. Exactly. So you can see it. And if you have any calculator problems, just give me a weird ass errors or the graph looks weird. I remember one time somebody came and says, my calculator has measles because they had it set so it had little dots all over the damn place. Just come up and ask me. Don't tell me after the final's over and say, man, I couldn't do that problem because my calculator. Why didn't you come up and just ask me? God, I don't want you to lose out points just because your calculator's freaking out, right? Or you don't know what button to press to make it stop freaking out. Just come up and ask me. Not a big deal. Cool? Now, if you forgot how to do something, you can come up and ask me. I ain't got to tell you shit, but you can still come up and ask me. I'll stare at you. Maybe I'll give you a hint sometimes. All right, is everybody with me on that? I think, so what do we get for R? I didn't tell you what was needed on the test here, did I? But for a sample of size 9, again, I'm going to tell you like I did on the last test. I just forgot to put it on here. But for sample of size 9, R's got to be... Stall, Jeff. R must be... Here we go. Good old lucky 0.666. So did we beat it? Yes, cool. In fact, for an even stricter test, it has to be about 0.8. And we're well above that. So what kind of correlation is this? Strong negative correlation. I love it. Kick ass. Because it is evidence of correlation, and it is decently close to -1. I'd say that's strong negative correlation. And we saw that from the graph. It was pretty tight to the points. The line is really decently tight to the points. Right? All the points are right there next to the line for the most part. And then part D says, predict a weight for someone who lives half a mile from Bronx Pizza. So how do I do that? Yeah, it's crazy. You replace x with 0.5. You can do it in the equation here. You can go out to the normal screen in your calculator, do it on the equation. Or you can do second calc value 0.5. There you go. I would predict somebody would weigh 217 pounds. Who lives half a mile from Bronx Pizza. It's the epicenter of obesity. I don't know. If you like pizza. If you don't like pizza, you're probably, I'm sorry for you, but you're probably better off. Or maybe you like Chicago deep dish pizza better. I don't know. Lasagna. It's not really pizza. Okay. Sometimes I say that and I have people that want to fight me. It's funny. What'd you say?
Yeah.
I said stuff. I heard things. I said things. All right. So that's number 5. Is that cool? Everybody understand what I want from you? What you got to show me? How to do it? This is your time here right now. Anything we went over during the formula sheet that you didn't remember? You tell me. Is that a My Little Pony theme? Yeah. Okay. I just wanted to make sure I wasn't seeing this. So anything from like the NAB stuff, you guys remember that? Yes?
How can I put the list 2 on number 5 again?
Say what?
The 2 mean the
Oh, yeah.
list 2.
So you do one var stats, but then you do it on list 2, so you hit second. See how L2 is above 2? 2. Enter. So then you get your mean, you get your standard deviation. Then you have to look up your t-score, right? Yes, ma'am.
Okay. Okay, so for 1, 2A,
Yeah.
so I know how to, I was able to figure out how to do it and everything, and then I got the same thing you got. I got 5.18. What I don't understand is why it's 0%, or what does that mean? Like, I don't know, I just couldn't connect it back to your answer, or like, what that even means.
So, on number 1, the mean of the population is 164.71. And then 2A says, what's the probability that a sample mean out of a selection of 32 adults? Probably the sample average amount of money spent per year on coffee. That's from when? That's from 1999. I'm sure it's probably a little different now. I've used this practice final for a little while. So what, of course, happens because of this? And because I'm asking a question about the sample mean now, right? I know you're with me on this, but before I get too deep into this problem, what has to happen? I mean, how do I find probabilities? How do I find probabilities?
Percentage.
True. How do I look up the percentage? I need to find the
Z-score.
Z-score first, using the formula, but the formula requires that I use the correct standard deviation. So when I take a sample and I ask questions about the sample mean, what has to happen?
You have to change the standard.
Standard deviation's got to change, right? So you make sure you change standard deviation. So your question is, if after you do all this work, you change standard deviation, you get the Z-score from that, you get like 5.18. And I've drawn my picture and I've shaded where the question is. So when I put this 5.18 up there, if you look at 5.18, the book's going to tell you 0.9999, right? I really desperately understand that you understand that that's full of crap. When they say it's 0.99 forever after that, that is so much bullshit. I wish they wouldn't do that, because the further you go up, the more stuff you're going to have below. It doesn't just suddenly stop at 0.9999. No. Maybe it's 0.9999992 now, right? So that's why I said, if it's off the chart, you could either do like the book says and say that's 0.999, but then what would this be? That's the question, right?
Oh, yeah.
1 minus that. But me, I'd say this is roughly 100%, so how much is on this side? Roughly 0.
Oh, okay.
Or if you said 0.0001, I would completely understand. You're doing what the textbook said to do, so I can't hold it against you. At the same time, I hope you understand how it can't possibly just become static, 0.9999 all of a sudden. It's going to still be changing, just changing very little, but still it's going to be growing as you go up, so there's going to be less and less stuff up here. So to a mere mortal, it would be about 0%. Right? Okay, cool. It's sort of asking a question like, what's the probability to go out and randomly select 20 people and their average height is 7'5", at least? Well, what's the probability of that happening? About 0 freaking percent, right? If you did the work, it would come out to be about 0 freaking percent. Yeah. Because that ain't going to happen, basically. Right? If it does happen, it's going to freak me out. You guys doing all right? I feel bummed out in here, man. What the hell? Yes?
I think you might have used the wrong, let's see. It was
Never know.
for 1C. You used 1.645 as the Z-score. I'm pretty sure it's 1.96. I might.
Which one is it?
For 1C.
Oh. So draw the picture. I mean, you can't. I'm not. That's not asking about a confidence interval, right? That's asking you P95. Well, what does that mean? Yeah. What did I just do with all of my... There they are. I'm so mean to myself. All right. So this symbol here means the 95th percentile. So it's going to be the Z-score that has what? Where?
95% area to the right.
Yeah, it's going to be a z-score that has 95%
Or to the left.
below it. So if you look up, I don't know why you look up 0.9, it's not a confidence level, right? Just look up 0.95 in the chart as close as you can get. You're going to get
Why do I
1.645.
always do that?
Yeah.
Okay, never mind. Oh, 1.645.
So why is this related to a 90% confidence level? Why does that make sense? How much is out here?
0.5.
So if I cut this to be symmetric, there'd be 5% out there, right? Which would have how much in the middle? 90. So that's why that z-score looks like it belongs to the 90%, because it does. So 90% confidence interval z-score is the same thing as a z-score that has 95% below it, which is what that means.
Okay.
So once we learn confidence intervals, we'll start to look at 95 in a certain way, but you gotta, this is what I'm asking it for. Not the 95% confidence interval, but the 95th percentile. It's a different thing. It's not capture that, it's have that much below me totally.
Okay.
Yeah. All right, some of you are really freaking me out. You look like you're about to have something explode in your brain. If you are ready for the final and you're going a little crazy now because you have no questions, you do not have to be here. I'm not holding you here against your will, right? Don't call 911 and have the whole movie happen that I've never seen. The one, I will find you, help you. Not Taken, but the other one, where the girl, that I've never even seen it, so I'm not going to stop talking.
I have the answers, but I don't know what I did with the test.
Oh. Okay, no, everybody's still here, and they're all looking the same. I'm not sure what to do with it.
I have another
They
question.
don't believe me. Yeah, sure. Good. So I'll tell you this. If you stay, shut up. If you need to talk, and you can leave. Yes.
Okay, so for number 3, okay, I was able to get everything now. Towards the end, when it's 75%, I just wanted you to go back and like remind me of like the rules as far as like, because for this one it had to be over 68%, right?
No, it has to be 68%. But there's 2 other things to consider. It's sort of like that problem I had on the last, I think it's the last test, where I asked you if it was about normal. And the problem is, I almost don't care if you get 68% within one standard deviation. The easiest way to tell if something's normal or not is, what does it look like? I mean, if it looks normal, the next thing you check is this. So what does it mean to look normal if I have it in a table form? What would it mean to look normal?
It's
Starts low, goes high.
Starts low, goes high, comes back low, right? This goes 11, 14, 12, 13, 50. Right? The last one's 0.5 at 0.50. Does it have any chance to be normal? So again, it's 0.11, 0.14, 0.12, 0.13, and then 0.5. Is that going to be normal? Please say hell no. Use the word hell.
well, what if it was rearranged differently?
No. I'm not asking about how can you change this to be normal. Can this be normal? It cannot possibly be. I don't care how loose of interpretation. Now, is it impossible for this to have 68% within one step? No, I could totally have 68% within one step. But the more important thing is, does it have the right shape? So the first thing you check is, does it have the right shape? And then if it also has 68% within 1, 95% within 2, you're like, yeah, it looks like it's pretty normal. In fact, the very first thing we did when we started graphing histograms, how did we tell if something was normal? We looked at its shape. We hadn't even talked about the percentages yet. That is the number one most important thing to check, is the shape correct? So it almost doesn't matter how the work part D comes out. The whole thing is it has no chance because it's not shaped correctly. The highest point is at the end. Yeah.
So, okay.
Okay,
So,
good.
okay, for that one it says,
Their brains won't explode.
might the data be normal? No, it should be 68%. So is that a rule? That's what I'm trying to remember is,
Yeah, empirical rule.
okay.
Within one standard deviation number, 68% for normal. Within two, there's 95%. I like that, said with confidence. And within 3 steps, there's 99.7. That's empirical. That's before we knew about the z-score chart that just kills that, right? It's just, now I don't need that anymore. I
You
can-
use the empirical rule when it's
normal.
not normal?
No, when it's normal. Chevy Chev is for when it's not normal. Yes? All right. I'll tell you on the practice file. What would a z-score of 2.14 tell us in general? That data point is 2.14 standard deviations away, or even better, above the mean. If it was negative, below the mean. But if you just stay away from the mean, I'm okay. Now, I can tell if you don't understand the concept and you're just trying to remember the words to use. Because very often the words don't end up making good sense, right? So what's more important is that you understand the idea. If you understand the idea, you don't have to memorize any wording. You just explain it to me in your own words. That's what it means when teachers tell you to do that. And it's one of the most frustrating things, of course. Read the chart and then tell me in your own words. You're like, I can see it. I can't make my own words now that I've seen it. What the hell do you want from me? But that just means don't memorize it. Just think the concept and then just tell me what it is. Oh, yeah, you guys are still here, so you get to benefit. There is one formula I did forget, for sure. This wasn't planned, but I'm sure why not. Remember this here?
Oh, I was going to tell you that.
I was about to point to the formula, and I was like, oh, we never wrote it up there. Why is this formula really, really, really cool? I don't know if anybody uses it this way at all, but it is a note. The z-score, if the z was 2, I'd have 2 of these from the mean to the data point. So the z-score is a number of standard deviations away from the mean to the data point. Bam! If I read it in English, it is a note. Right? So you're allowed to have formulas in formulas, not notes, but there's a loop around. That's a formula that is a note. Right? Kicks ass. Plus, you might need to use it. Right?
You said a number of standard deviations.
Yeah, the number of standard deviations from the mean to the data point. Yeah, it's almost too cool if you let it be. Yes, ma'am.
Are you gonna ask us any problems that like aren't on here at all?
It depends on how you.
Like, are you gonna ask us
All the concepts
Okay, that's what I meant.
that are represented on here could be represented on the actual final. Right? And that's nowhere near specific enough of an answer for any student, but that's too damn bad.
So you're like,
I actually had somebody ask me this morning, in all earnestness, I love it. She said, can you tell me, I know you can't tell me what's going to be on there, but can you tell me what's not going to be on the final? And she was just very earnest. I'm like, what? No. I said, this is what every student wants. And no, I can't. No, I'm not. Screw that.
so there's, okay, because I know there's concepts that you, like, mentioned on here, but there's other forms of doing those type of problems. There's, like, a lot of different forms to do, or not the same problem, but, like, there's problems like them that are a little bit different, and they're a little bit way different of doing them. So are you going to do that? Like, that's kind of what I mean.
Like, give me an example.
Like, how...
Say again?
Is it like the high and low and the T equal, and there's like 3 different forms of it?
You probably will. You probably will. I don't even know what I'm asking. Because okay, like
I'm not even
say,
sure what that is.
like you didn't put too many problems on here, like dealing with like T-scores and I don't know. I have to figure out a smart way to ask my question.
Number 9.
Like how you have all these different. Well, I guess then that answers my question.
Yeah. Number
Like,
9 is a
how
T-score
you have all
problem.
these different
I don't have any
numbers.
like chi-square stuff, but that's definitely going to be on the file. Yeah.
It is, if you change number 6.
Yeah.
For number 6, what the meaning of the average has now changed?
Yes. So the average has now changed. So if the average used to be 1.43, and they think it's now changed, how would you say that mathematically? The mean, if it's changed, the mean does not equal. So how many tail tests? 2. So a 2-tailed test is almost always going to be, we think it's different, we think it's changed, but it could also be, we think the mean is this. Because then the opposite would be not that. That would be a 2-tailed test, because it could be higher or lower to be not that. Yeah. In fact, the symbol for this used to be this. That was statisticians, and the math people came in and said, no, you can't have 2 symbols in a row, crazy people. But that kind of made more sense in a way, because then it's less or greater, and then it's pointing in both directions, like, oh, it's 2 tails.
Can you do number 10 from like beginning to end?
Sure, man. Nobody else is asking anything. It's your floor right now. Let's see. Let's see. So you feel the percentage of students with more than 2 files has increased from previous years. So what's your claim? What was it previous years?
It was 0.387.
0.387. So what's the claim?
P is greater than 0.387.
I like it. So which one is that going to be?
H1.
H1? Then we say that I think H1N1. But we're past that. We got worse stuff coming now. Gotta get my flu shot. So how many tail tests is it going to be?
1.
1. In fact, where's that tail going to be? Yeah, because that always sets it up. H1 always sets up where the tail is. It points in the direction of the tail. It's going to be up here. To show evidence for this to be true, which is what we're always doing, independent of which one we hope is true. The purpose of the test is try to show evidence that this is true. Or, you know, the same thing is show evidence that this is not true. Right? So that's always going to set up where I'm going to find evidence for these things to happen. It's going to be so far away. In this problem, do I use Z or T?
Well, no T's.
What's up?
No T's.
Good. So it can't be T now, but you still got to show me why it's Z.
Why can't it be T?
Because it's an NPQ problem, right? It's either normal enough, so Z, or it's not normal enough, so nothing. So what do you got to show me for an NPQ problem? NP and NQ has to be greater than or equal to 5. So what's N here? 292. And what's P? 0.387. The gas, right? There's no hat on this little dude, right? So don't get that from the sample percentage. It's P. It's just straight up P. It says 0.387. So this would be 292 times 0.613. Gas, the Q part of that. So anytime you want to make a confidence interval for a percentage, you want to do a hypothesis test on percentages, you have to show me it's normal enough, and that's the test for normal enough. I don't care that N's greater than 30. N does not have to be greater than 30. NP and NQ have to be greater than 5. And of course, this is going to work out, whatever the hell that is. I don't even know. 20, so 111. No, I don't know. What is it?
113.
One who?
113.
113 points blah, 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 is bigger than 5, and this will be 180, 178 point something or other, that's bigger than 5. All right, so far so good. So still the same steps. What's the hypotheses? What are we going to use to talk about this stuff? Step 3. So of course this means it's normal enough. Yeah, this is going to be about the rejection region now, right? So here on this problem, alpha is 0.09. That kicks some ass. So you can't use your t-score chart. I know we were not supposed to use t-scores, but again, z-scores at the bottom of the chart. But you can't use it because it didn't have a 0.09 on it. Nah. So you got to go back. You got to do things the old-fashioned way. That's a really old joke. Someone's got it. So I have a one-tailed test. I want how much area in here? 0.09. Which means how much area is down there? 0.91. So can you find the z-score that corresponds to 0.91 below it, or at least close to it? Yeah, probably the one I have on the answer key. What was it, 1.34? You guys understand how to get that? In case I do that? You know I'm going to ask you for like a 92% confidence interval, something like that. You know I might ask you like something like the same kind of idea, which is you have to go back to the actual z-score chart to get the value, right? Okay, maybe. So if z star is greater than 1.34, we'll do what? Reject the hope. Support the high.
That's
right?
the same thing as saying what you wrote on here, because you wrote if p-value is less than
Oh yeah.
1.0.
So if I want to use the p-value method, if the p-value is less than alpha, we'll do the same things.
Okay.
So the z-score method is the number of standard deviations have to be more than something. It's got to be far away. But if it's really far away, then it's got a very small tail. So they mean the same thing. If my tail is smaller than alpha, or if my z-score is bigger than z critical, they both mean the same thing. They both have the same results. Be far enough away. Cool. Yes, ma'am.
I missed what you did to get the 1.34.
So 0.09 is in that tail, which means 0.91 is below that. If you look 0.91 up in the z-score chart in the area, you find the closest z-score to that. Looks to be 1.34. So now I've set up what I have to do. I'm going to go see if I did it, right? Step 4 is calculate what z star is. So what do we know from our sample? What's p hat?
122 over 292.
292.
And how far do you take this out at least? 3 places. I like it. All right. When in doubt, go 3 places. So whatever that is.
4.18.
No.
0.418.
Oh, 0.41. Is that right? Is that cool? So then, what z-score? That's everything I need for the z-score formula. P hat minus P over square root of PQ over N. So it's going to be my value minus the supposed middle divided by square root of the P Q, which we figured out earlier, over N, 292, not 122. So the biggest mistake I see people do here is they put P hat and Q hat in there. No. They put 122 instead of 292 down there. No. Right? And it doesn't take much to throw this thing off. And then just double check and make sure you get the same thing I did. I got, oh, that's test 3, Jeff. Where do you have your, there we go. What did I get? Oh, there's more pages than that. There we go. I got 1.09. Is that what you guys are getting? How do I find the p-value?
From the area code.
Yeah. So the alpha is the area and the tail that this guy makes. P-value, now my z-star of course is down there because it's less than that. P-value being the area of the tail that my z-score makes. Same exact way. So if you look up 1.09, you're not going to get the right value. If you get a p-value more than 50%, you're probably wrong. Right? It should be something smaller than 50. So you look it up, and then you do 1 minus, and you get there. And I got 0.1379. So either way you look at it, my z-star wasn't far enough, which means my tail was too big. All right, don't talk about it. I'm very sensitive. So the p-value here was 0.1379. Either way you look at it, what do? Do we succeed or fail? We fail. We totally fail. We fell short, right? We didn't find enough evidence. This was the evidence line. We didn't do it. So we fail to reject the hope. We fail to support. Which language am I going to use for the conclusion? Because my claim was H1. So I'm going to use this language. We have not found sufficient evidence to support the claim that the percentage is more than that, blah, blah, blah. There's no ambiguity at the end. You just match up one of those two statements with what the actual claim is, and that's the language you use. I still have people using support when they should be using reject. It all depends on what the claim is. The claim here was H1. I used the thing about H1.
So you only have to do that part of it, you don't have to say, so you fail to support H1, but you don't have to
so
like...
there's the step 5 that I was trying not to do. So fail, so we have not found, and I've already done it actually, so I know. We have not found sufficient evidence to support the claim that, and then you go back and you just write exactly what I said the claim was.
Okay.
Yep. Don't say to support H1. That's not good enough. You got to tell me physically what's going on. I know where you are. You're in that weird area where it's almost over, but it isn't. So that's why you all look this way. You're all freaking me out. Yeah.
If the claim was HO, how would we word that?
Then we word it using this language. We have not found sufficient evidence to reject the claim that blah, blah, blah. If you think about it, it makes sense. We didn't get so far away, so it looks like the middle actually is about this. So it looks like this guy's right. I definitely can't be greater than, we just didn't get far enough away to show evidence for that, right?
How do we, okay, what I get confused at is, like, how do I know what Z is? Because you could say this in different forms. You could say if Z star is greater than 1.34, we would, never mind.
You can't really say it in different forms, can you? I mean, once you draw the picture and you know the rejection region is going to be out, it's going to be in tails, right? Then there's only one way to write the statement that corresponds to that. And the rejection region is all about rejecting the null, supporting the high. So, I mean, that's the only thing you can say here when you say this in words.
Oh.
That's it. All you're doing is identifying when this happens. This is going to happen in the rejection region. This first piece is, tell me in words where the rejection region is. So, of course, the rejection region is above 1.34, right? That's all it's saying. If I get above 1.34, I'm in the rejection region. So I'm going to reject the null, support the high.
Say this was different, though. Say, okay, like...
So if I had one where it was a two-tail test and it was like negative 1.78 and 1.78. Now tell me in words where the rejection region is. do it. Where have I shaded it?
If Z star is less than
Yes.
negative 1.78
Beautiful. Or
greater than
1.78, then guess what you do? You always do this. You're just identifying to me where this region is. It's called the rejection region
the
because
rejection region is always stated in that formula.
this way, exactly.
Okay.
Good. That's it. There's only one thing you could say here, which leads to only two things you could say here. Either
Yeah.
we did this, or we failed to do this.
Oh, okay.
And then the conclusion is, which one's the claim? I mean, it's nowhere near as amorphous or like vague as people think going into it. It can't be. It has to be very clear, very precise.
Okay.
Of course, in the background of it all is always alpha, which is saying, you got this chance to be wrong. And we're like, we're human, we're okay with that. We understand being wrong. We always have a chance to be wrong. Yes?
Can you find your on number 5?
So number 5, we did that earlier. That was in the calculator, right? We did linear regression to find R. Right, so we did stack calc number 4. And then here's our R.
Could you graph that again?
Does it show up? No. Okay. Is that the one you're going to use at the test? Yes.
No,
Okay.
not
Not this one.
yeah.
You're going to use a different calculator? Okay. So on the day of the test, just come to me with your calculator at the start of the, and I'll set it up. Yeah.
So what would we do after that to
Zoom
to see
9.
the line?
Oh, you have to go to y equals and put the line in there. And clear that plus sign out of there. Otherwise it'll freak out. It's your eye.
Oh yeah. Oh, I have a bunch of questions for you actually. Okay.
Looks like everything hinges on you because nobody else is asking me anything. So they're just waiting to see what's being asked. So if you don't ask anything, you're not going to get anything.
So what do I do after that?
Hit graph.
And then zoom.
Oh, you didn't do zoom yet. Okay, hit zoom 9. Thought you already saw your little points. Did you hit zoom 9?
I thought. I go down to 9, right?
Yeah, you just hit the number 9. All right, so look at your. This is yours.
Yeah.
So your stat plot is turned off. So if you just turn it on and you don't turn it off, now do zoom 9. Oh yeah, trust me. There's no way I could possibly look at all the homework. So I just put in the computer, and as far as I know, it's good. Yeah, it's a bit of a trade-off. Since I didn't have time to grade it for you, then it's fine. I wish I could make homework worth nothing, but then no one would do it, and you'd all would die. It would be bad.
That would be awesome.
It would be so bad.
But we can
If everybody did what they're supposed to do, it would be awesome. But I tried one semester, like the second semester I taught, I tried to make homework optional or whatever, and oh my God, halfway through I had the most D's I'd ever had. I'm like, of course, I was only a second. Never again after that, never again. I always have to make homework or something. Really, don't do homework, you're screwed. Yeah.
Can we still return the homework and
Yeah, if there's anything you had to correct, or if there's anything that you haven't turned in yet, if there's any corrections you haven't made, even like quiz 1, right? You'll have to get them all right pretty much by this point to get anything, right?
meet you on Monday next Monday?
Yep, due by the day of the final.
Did you do that?
Huh?
He would make homework kind of optional. It was if you got an A on the test, your homework grade would reflect what you got on the test. But if you didn't get an A, your homework grade was what it was when you
Oh, I
turned it in.
see.
So if he would, if you got an A, your 8% would be your
Would also
grade
apply to your
for
homework.
percent.
I gotcha. Yeah, I like that.
It's a good idea.
Yeah.
Oh yeah, could you just show really quickly how to put in the, I don't know what they're called, but when you have the C, you have like the choose.
Yeah, so you have, if I were to do 8, choose, so I'll go to math, probability, number 3. Go over to PRB, number 3. 8, choose 2, for example, 28. If I had 8 people, there's 28 ways to choose 2 of them to go do something.
So you went over to math. And
Hit
then-
math, go to PRB, number 3, choose. Oh, so you both just had this before? Oh, what did I do that to? I'm evil. I might have changed it halfway through. Wait, let's see. 8. Yeah. So you'll like this. All right. So you see, if you add them all up, you get 38, right? And then cut that in half, you get 19. So if I give you that 1 point back, it's 37, but then I round up 38. Divided by 2 is still 19.
Still?
Yep. Sorry about that. Oh, be more specific. Exactly 1.64 z-squared tells me that it's 1.64 standard deviations from the mean to the data point.
So I need to put 1.6.
Yes, cool.
So
So if I just say, what does the z-score tell you in general, you're okay. If I say, what does the z-score of 1.64 tell me, use 1.64 in your answer. Yeah, 1.64 standard deviation.
Only from the mean to the data.
From the mean to the data point. I like it. Oh, remember, just if I find correlation, we found evidence of correlation, even if it's not really strong. There's still evidence of correlation, but that doesn't mean something causes something else. I don't know what causes what, and in fact, maybe it doesn't even cause it. It just sort of sometimes happens at the same time. So if we suddenly start not letting the other team, we're better against them, we don't let them go, they might still get some lucky plays off. You never know. I don't know if it's going to make things. Because what if we never score any points? Then, we're not going to win. The main idea there is causation. Correlation does not imply causation. Just because there's a correlation doesn't mean that one of them causes the other one to change. It just means that it looks like they both change at the same time. I don't know what's causing. Maybe one does cause the other one to change. Maybe it's a part of the change. But I can't say for sure. Yeah. Oh, sure.
Do you have any more like of those sheets that tell you how to do stuff on the calculator?
Not with me. But I'm pretty sure I put it up on the website, didn't I?
Should
Okay.
be on the website.
Yeah.
Alrighty.
What's wrong with this?
Oh, yeah, because from a sample we found standard deviation, so we have to use t-scores.
Okay.
Yeah.
Even though we know sigma.
No. We don't know sigma. So where does 30.75 come from?
Oh,
From
okay,
a
from a
sample.
sample. Okay.
Yeah.
T-squared, we might have to use T-squared, T-squared.
Yeah, so T-scores are when it's normal and we don't know the population standard deviation. And we don't. We only know the sample standard deviation.
Thank you.
Sure.
Can I like practice answer?
No, sure.
Yeah, that's